What if the things that made up your table salt and electricity in your homes all came down to how atoms share or give up their electrons? Well, that's exactly what's happening in the world of ionic bonds. Today, we are diving into how these bonds form and why they are so important in creating stable compounds. Stick around because by the end of this video, you'll be seeing chemistry in a whole new light. Has it ever occurred to you why salt dissolves so easily in water? The secret lies in its atomic structure. Inside every pinch of salt, sodium and chlorine atoms are held together by ionic bonds, a special type of chemical bond where one atom gives away electron and the other snatches them up. But what really happens during the formation of an ionic bond? Let's explore this process step by step. So, what exactly is ionic bond? It is a chemical bond formed when an atom transfers electrons to another atom, creating oppositely charged ions that are strongly attracted to each other. The atom that loses the electron becomes a positive ion, which is a cation, and the one that gains electron becomes a negative ion, which is anion. I talked about cations and anions in our previous videos. Now, let's break it down with an example. Sodium has one electron in its outermost shell, while chlorine has seven. Sodium is eager to get rid of that one electron to achieve a full shell, and chlorine is just as eager to gain one electron to complete its outer shell. So what happens next? Sodium transfers its lone electrons to chlorine, resulting in Na plus and Cl minus. Once sodium loses an electron, it becomes a positively charged ion, Na plus. Chlorine, now with an extra electrons, becomes negatively charged, which gives Cl minus. These opposite charge attract each other strongly, forming the ionic bonds that holds them up as a compound to give sodium chloride, which is also known as table salt. So now let's take a look at properties of ionic compounds. Ionic compounds like NaCl form crystal lattices where each positive ion is surrounded by negative ions and vice versa, creating a very stable structure. This regular arrangement gives ionic compounds some unique properties. For instance, ionic compounds are usually solid at room temperature. They have high melting point and boiling point. And when dissolved in water, they can conduct electricity. This is why salt water is a great conductor of electric current. As a quick challenge, can you think of any other ionic compounds you use in daily life? As I have said, sodium gives up its electron to chlorine and they bound to form this stable compound. But there are many other ionic compounds around us, like calcium carbonate, which is found in chalk, or magnesium oxide, which is used in fireproofing.